Our goal here is to evaluate some algebraic expressions given values for the variables. So here I have evaluate 2x plus 9 for x equals 6. So when I look at 2x plus 9, it can take on a lot of values. It just depends on what the value for x is. Could be anything, right? X can vary, thus the variable name. So it could be anything. However, in this instance, I want to know what is that if I choose a value for x, specifically 6. So what I'm going to do is substitute this value 6 in there for x and see what I get following the order of operations. So x is 6. What I like to do is just replace my variable with a pair of parentheses and then take that guy and write it in those parentheses. The reason I like to do that instead of just writing it there or remembering its multiplication after the 2 times the x, I don't need to remember anything when I'm substituting. I just need to figure out where do I need to put the number. So now that I have it in here, I know that this is one way you can write multiplication. So this is 2 times 6, and then I have plus 9. Thinking back to gems, I've got grouping, no grouping, no exponents or roots. Multiplication and division, so I'm going to multiply first. 2 times 6 is 12, and then 12 plus 9 is 21. So when x is 6, this expression is 21. Okay, of course this expression would be a different value if x were a different value. I just want to know for this one instance, though, what is this value for the expression? Okay, great. Here's another one. I want to evaluate x squared plus 5x for x equals negative 3. So I have the same idea here. I have this expression, x squared plus 5x, and instead of the x, I want to substitute in this value, negative 3. So I will draw my parentheses. Okay, that's where the x's were, so that's where I want to write this negative 3. So I need a negative 3 in here and a negative 3 in here. Notice that my parentheses help make sure I don't end up subtracting or something weird over here, right? This was 5 times x, so I want to make sure that I take 5 times negative 3 when I substitute that value in. All right, exponents. I do have an exponent. I have negative 3 squared. That means take negative 3 times negative 3. A negative times a negative is a positive. 3 times 3 is 9. So this is 9 plus 5 times negative 3. Okay, I'm done with grouping, done with exponents, down to multiplication. Multiplication beats addition. So I'm going to take 5 times negative 3 and get negative 15. And now if I'm at 9 degrees and I add going down 15 degrees, I'm going to end up negative at negative 6 degrees, or getting rid of the degrees, at negative 6 here. That's something we here in Wisconsin have an advantage of, is we understand how temperatures work below 0, so we can definitely start at a positive and go down more than we've got and be like, yeah, it'll be negative degrees. So anyway, negative 6 is what I get. So this expression, when x is negative 3, has a value of negative 6. All right, in this example, I want to evaluate x squared plus 3xy plus 2y squared for x equals 3 and y equals negative 4. So again, I'm interested in what is this expression for those values of x and y. This time I have 2 values to substitute in, and I just need to make sure that the letters that I'm replacing are replaced with the correct values. So those variables that I've got, I put in the right things. Sometimes I'll do that by using different symbols, different grouping symbols for my places I'm going to put in. Sometimes I won't. Sometimes I'll just go for it. This goes here, this goes here, so this goes here, this goes here. Okay, 3's in where x's used to be. Great. Now, I want negative 4 is where my y's used to be, so a negative 4 and a negative 4. If you're substituting multiple values, it can't hurt to pause for a second, take a step back, and make sure that you have things where they belong. I had an x squared, great, plus 3 times x, yep, x is 3, times y is negative 4, plus 2 times y squared, y is negative 4, I've got that thing squared, great. Now I'm all set to just go for the order of operations and figure out what the value of this expression is. Don't have anything to do inside of grouping symbols, so I'm going to start with my exponents. 3 times 3 is 9, plus 3 times negative 4. You can see I'm totally abandoning the brackets now because I've got my values in correctly. And then 2 times negative 4 squared. Negative 4 squared is negative 4 times negative 4 is positive 16. Now I've got a little more multiplication to do. 9 plus 3 times 3 is 9. 9 times negative 4 is negative 36. And 2 times 16 is 32. Now, my order of operations says I've just got addition here, so I should do it from left to right. I find that most people don't. They key in on this would be easier to do first, giving them negative 4. 9 plus negative 4 is 5. But I'll write it in the order from left to right anyway. 9 plus negative 36. 36 minus 9 is 27. And 36 was way bigger, so negative 27. And negative 27 plus 32, of course, gives me 5. So, this expression for both of these values is 5. When x is 3, y is negative 4, that whole thing is 5. Let's just do one more here. I want to evaluate 6x plus 2y all over 9 plus y for x equals negative 4 and y equals 6. So again, I'm going to take my expression, 6 times x plus 2 times y all over 9 plus y. So where do I want this negative 4? I want it where x used to be. That is the only place x used to be, so I got that. And then I want a 6 in there for y. Here's a y, here's a y, there's a y, there's a y. Again, I paused just to make sure that I got those in the right place. Yeah, I feel pretty good. So now to evaluate this. I do have grouping symbol this time. This fraction bar tells me do the stuff in the numerator, the top, do the stuff in the denominator, the bottom, and then you can think about dividing. So don't divide first. Do the stuff in the numerator, do the stuff in the denominator. So in the numerator, I don't have grouping. I have no exponents, so I'm to multiplication and division. I see some multiplication. 6 times negative 4 is negative 24. And 2 times 6 is 12. And this is over 9 plus 6. Okay, so still in my numerator, negative 24, looked at it and saw the answer instead of what I wanted to ask. Negative 24 plus 12 is negative 12. 9 plus 6 is 15. And now I'm done with the numerator and done with the denominator. I see I have a fraction. I'm going to write that negative sign in front of it. And 12/15 can be reduced. They're both divisible by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. So I got negative 4/5. This thing for these values is negative 4/5.